SSL, there's nothing preventing browsers from trying to open a plain text connection to it. And in some cases, even that is enough for the secure connection to be compromised. So we need to look into how, there's already a feature for this, for this DNS server records, which are used for some protocols, but not currently for HTTP. Anyway, we're moving on. With some, so in the previous step, we had like 700,000 domain names. We looked at the 100 servers from the Alexa's top 1 million domain names. And we actually extracted quite a few domain names from certificates themselves. And by combining all this information, we basically arrived at about 860,000 known SSL servers that we wanted to look into. Because we know that there's about anywhere from between 1 million to 2 million commercial SSL certificates in the world. These are numbers, for example, given by Netcraft, who's been following the SSL market for a long time. The number of servers that we're looking at in this survey is from 25 to 50% of all valid SSL certificates on the internet. It's worth saying that the data set is probably very biased because we looked mostly at the top level domain names and not on the country specific ones. So as you may know, certificates will sometimes say contain information about the organizations that own them. And so we extracted that information from where it was available. And you can see the chart there. For most certificates, we didn't know. The origin was unknown. But you can see that about more than 200,000 were US-based, and then followed by some from Japan, Great Britain, Denmark, and so on and so forth. Anyway, which sort of brings me to the main feature of the presentation, which is the results of the SSL survey itself. So what happened is that in the second phase of our survey, we actually needed more processing power. So in the end, we ended up using 3 servers, with 2 of them performing assessments in parallel, each server contributing about 2 to 3 assessments per second. And assessment would actually take quite a long time. We calculated the median value to be about 65 seconds. The network latency is what impacted assessment speed. So if a server is particularly close, we could complete the assessment in a couple of seconds. But for a server that's very far away, it may take even thousands of seconds. Anyway, what this proved is that, however, the resources that we used were pretty modest. And there was about 1 terabyte of the traffic that we used. All these 3 servers were virtual and quite modest when it comes to performance. So by far the biggest resources that we used was time. So, and I estimate that I've spent anywhere from 1 to 2 months full-time working on the study, making sure that everything works well, and validating results and fixing small issues and making sure that the results that we get are correct. So without further ado, let's move on. So if you recall, we had about 860,000 certificates. So in the first step, we wanted to look as to how many certificates we trusted. So trust is a somewhat subjective term. In our study, we used the trust base of Firefox 3.6, which means that Firefox will trust a certain number of root certificates which it has in the trust base. And the results here should be reasonably accurate and comparable to what you would get browsing using Firefox. Although we did use slightly different technologies, so there may be some variations. And that's one thing else also that we discovered is with SSL, interoperability is still a problem, as I'll mention in a moment or two. So by far, we trusted about 70% of all certificates that we had in the database. But there's also a small group of suspicious. What we discovered is the interoperability problem. It seems that the Java implementation of SSL has some problem with a certificate issued by a certain certificate authority. And so we think the overall number of trusted certificates is about 72%. For this test, I also did an independent analysis using OpenSSL, and we arrived to pretty much the same number. So it's about 70–72% of trusted certificates. If we look at the causes and why we couldn't trust certain certificates, by far the biggest problem was expired certificates. Either certificates that someone forgot to renew or those that were abandoned. The second was quite a large number of self-signed certificates, 96,000 of those, who are really not fit for public consumption, although they may be perfectly fine for those who know what these servers contain. And then the next is a similar problem, which is unknown certificate authorities. And this would be the case of people creating their own internal, perhaps, certificate authorities, which they would then use to sign certificates. And generally speaking, this group also is not fit for public consumption. There were about 20,000 certificates where we had interoperability issues, which we verified, and it's transpired that sometimes there will be sites that work with OpenSSL, but will not work with the Java SSL, but will maybe not work also with the Firefox SSL. So there are these issues that we will want to dig deeper in the future. There was a very small number of revoked certificates, only about 1,000, and there was a surprisingly large number of certificates whose subjects were malformed because they contained multiple common names. And I suspect these certificates were not issued by certificate authorities who would probably catch these problems. So these were probably self-signed too. Looking into expiry dates and validity of certificates, you can see that most certificates are valid for a period of 1 year, and then you can see spikes at 2, 3, 4, and 5-year ranges. And looking just at the expired certificate, by far the largest number of these have expired relatively recently, and so within a month or two, and then the number will go down rapidly, and it will just, you can still see that after 2 or 3 and even 4 years, there's a significant number of certificates that are still expired. And also looking at various problems, most certificates had only one problem, which is that they expired. But there's a number, about 38% had some other problem too. And perhaps they were self-signed or issued by an unknown certificate authority and so on. Then we looked into the unknown issuers. And these were issuers that we couldn't trust because we couldn't find them in our trust base. And we realized that the great majority of these, there were about 43,000, we saw only once or twice, which means that someone generated a CA and used it internally, and it's not a proper CA. There were only 22 certificate authorities that we saw more than 100 times, and I manually inspected every single one of them just to ensure. Of that list, I found 4 legitimate authorities, but they, CAs, for example, First Server Encryption Services is apparently a subsidiary of Yahoo in Japan, but it's not trusted by Firefox, and it's not trusted by other major browsers too. CA Cert is a certificate authority that is also not trusted, although they make an attempt to issue certificates and they have a long-term goal to be trusted. But you can see that they have quite a few certificates too. And there are 2 legitimate certificate authorities that are not trusted by Firefox, although they are trusted by other major browsers. And for what I could figure, they're not trusted only because they haven't completed the procedure where they would include their certificate into Firefox. Anyway, the point of this exercise is to make sure that we really trust only those certificates that we're supposed to trust, and that we're not missing a large number because of some internal problems. And then we looked into trusted issuers in the chain, the certificate chains. So normally, the way it works, you have each browser or SSL client will have a trust base. For example, Firefox has at the moment 155 of these. And those trust anchors will either sign web server certificates directly, or they will sign them through an intermediate certificate authorities. And the chain of trust can be of any size. But what we found is that, and the minimum size is 2. So in the table in the right lower corner, you can see the number of certificates that had a chain of particular length. So you can see that most certificates actually have the chain length of 2 and 3. And currently the chain length of 3 is recommended. That's generally because if you have a trusted anchor, the root certificate, you want to put it offline. You don't want to use it all the time to basically sign web certificates. So what you do, you generate an intermediate one, and then put that one online, so that can be used all the time. So one interesting point is that although we saw 429 certificate authorities, they only led to 78 trust anchors out of 155 that we had in our trust base, which is about only 50%. So even with Firefox, only 50% of trust anchors were used. So, and then we looked into these chains to see whether they're correct. We found that, strictly speaking, most of them are correct. And there's a small number of certificates of chains that are incorrectly formed for 2 reasons. There's often, so you can see about 6% of these are not correctly formed because they're missing intermediate certificates. So when you have a chain of trust, what you're supposed to do, you're supposed to include your web service certificate, but also include all the intermediate certificates, but not the final certificate, the trust anchor. So what we also found, so some chains will be incomplete, and also in some cases, the chains will be in incorrect order. The issue with this is not all SSL clients will know how to handle incomplete chains or chains that have incomplete orders. So these sites that do not have this implemented correctly can experience apparently intermittent problems with the SSL access that will be very, very difficult to troubleshoot. But there was one really unusual thing that we discovered, is that 43% of all sites actually send more certificates than they need to send. And those extra certificates will actually create a potential performance issue in bandwidth for them. So if we look into them, we can see a certificate is usually about 1 kilobyte long. So if you send an extra certificate, that increases the size of your SSL handshake by about 1 kilobyte. And what's very important about TCP connections is that initially they start off slow, and they sort of ramp up speed as the number of packets is exchanged. So the bottom line here, the sooner you complete the SSL handshake, the sooner you will start receiving actual data. If you have a handshake that's too long, then that will take more packets, and then the whole handshake will take actually quite a longer time. So you can see that quite a few of these certificates servers send more certificates than they should, and no single. You can see in the table on the right, the first column displays the actual number that we saw, and the column to the right actually displays the number of certificates we should have seen. You can see that no server needs to send more than 5 certificates, but there was actually quite a large number of sites that send more, and there was even one site that sends 116. So this one site probably had a SSL handshake alone on 120 kilobytes of data, which is a tremendous number, which will slow down the handshake quite a bit. And this is just a matter of misconfiguration. It's something that can be relatively quickly, and just someone that needs to do that. Now, the reason I looked into this problem, and the reason why so many sites actually send more certificates than needed, is because those are the instructions that they get from their certificate authorities. So I had a certificate that I used for some of my websites, and I saw that I had my site suffered for this problem because I just took the chain that was given to me by the CA and installed it in the server without really realizing that there's one certificate too many. Anyway, this is not going to be a problem for most sites, but for those sites who want to really squeeze every single bit of performance, they really need to look into this. The other thing they need to look at is session